So we're doing the converse of what we learned in lesson 6-2. There we learned that if a quadrilateral is a parallelogram, we know a whole bunch of things. For example, that the opposite sides are congruent, that the consecutive angles sum to 180, and that opposite angles are congruent. Okay? If we knew it was a parallelogram, then we knew these things. In this lesson, we're doing the converse, or going in the other direction. If we know that opposite side pairs are congruent, we can determine it's a parallelogram if we didn't know it at the start, okay? If we know that we've got some angle and both of its consecutive angles are supplementary to it, then we can determine that it's a parallelogram, okay? If we find that in a quadrilateral, the opposite angles are congruent, we can determine it's a parallelogram. That's the idea, and we'll apply that. So here you can see we've got measures for the opposite sides. For what value of y must PQRS be a parallelogram? Well, whatever value of y makes the opposite sides congruent and equal in measure. So what do? The first thing we're going to do, since we can't solve an equation in two variables if we just have the one equation, x plus 2 equals y won't help us unless we know something else. So we'll start here and we'll say, let's find out what x is. Set these equal to each other, because the only way that it's going to be a parallelogram is if the opposite sides are equal. So we set this equal to the other side, and we solve out to find that x equals 6. Now that we know that, we can say, okay, now we can find out what y is, because we can take the equation x plus 2 equals y and replace x with the value of it that we know. And we find that y is equal to 8, so for this PQRS to be a parallelogram, we know that the value of y must be 8. So then, for this figure at the right, for what values of y must EFGH be a parallelogram? Solve this out, and when you restart the video, you'll have your answers. Okay, so the big idea here is that we have consecutive angles with the same variable, makes it really convenient, need to be supplementary in order for this to be a parallelogram. So we can say 3y minus 2 plus y plus 10 has to equal 180, and we can solve that to get y is 43. And these two consecutive angles need to sum to 180 as well, so 4x plus 13 plus 12x plus 7 equals 180, and it solves to be x equals 10. So those are the values of x and y. And you can see this is actually covered up, sorry, it should say and variables x and y right there. Okay. Just a note, the other thing you could do is set 3y minus 2 equal to 12x plus 7 and y plus 10 equal to 4x plus 13, because opposite angles also being congruent would do it. In that case, though, then you would have equations in two variables, and you would have to use solving systems of equations to solve it. You could still do it, and you'd get the same result, just a little trickier. So you're better off doing these two added together equal 180, and these two added together equal 180, because you get equations in one variable. Okay, so here we find out that if the diagonals of a quadrilateral bisect each other, then we know that this is a parallelogram, okay? So they say that AC and BD bisect each other, prove that it's a parallelogram, and this is a proof of this theorem, okay? I'm gonna show it to you, I'm gonna let you read through it, and you can ask any questions as you want, rather than going all the way through it, but here it is, an explanation of this theorem, so you know that it's true. All right, so this theorem is not really the converse of another one specifically, and I'll explain why in a second. Okay, if you know that one pair of opposite sides is both parallel and congruent, you can determine that it is a parallelogram. Okay, the reason that it's not a direct converse of a theorem is because if you know that it's a parallelogram, if you start by knowing that a quadrilateral is a parallelogram, you don't just know that one pair of sides is parallel and also congruent. You know that about all of it. Okay, you know that both pairs of sides are parallel and both pairs of sides are congruent. Okay, so going this way, what we're basically saying is we don't need to know that both pairs of sides are parallel and both pairs of sides are congruent. But what we do need is that it's got to be the same pair of sides for both conditions, parallel and congruent. Here's an example of one that's a quadrilateral, and the sides, each pair of sides has one characteristic. This pair of sides has their parallel, the other pair of sides has their congruent. Okay, as you can see, it's possible for one side to be pointing in one direction, one side to be pointing in the other direction, and so you get parallel and congruent, but it's not with the same pair of sides for both, and so therefore it doesn't automatically force it to be a parallelogram. Okay, so be careful of that. It's got to be the same pair. Now, we're going to decide whether it is a parallelogram. Can we prove, based on what we know, that the quadrilateral is a parallelogram? Okay, based on what we were given. We've got here that opposite sides are congruent, and we have these two angles at 50 and 130. Prove that it's ABCD is a parallelogram. If we can, we might not be able to. But as it turns out, because these are supplementary, and the only way that these consecutive angles are supplementary is if these two sides are parallel, we know that side AB is parallel to side DC. Okay, same side interior angles are supplementary. And we also know that the opposite sides are the same length. So we have, based on that last theorem, one pair of sides that's both parallel and congruent. So we can say by theorem 6-12, we know that that's a parallelogram. What about this one? We have this side congruent to this side congruent to this side. Okay, is it enough information? How could we prove it? Well, as it turns out, we need opposite pairs of sides congruent, not consecutive sides. Okay, so we don't have opposite pairs of sides congruent, so we cannot prove that this is a parallelogram. Does not mean that it's not, we just don't know. There's a difference there. Okay, so what about here? Can you prove that this quadrilateral is a parallelogram based on the information? Can you prove that this is a parallelogram based on the information? Okay. I'll stop the video, restart it when you have your answers, and we can check them. Okay, so like I told you in my example for theorem 6-12, to have one pair of sides congruent and the other pair of sides parallel is not enough. It's got to be about the same pair of sides. One pair of sides is both parallel and congruent. And since this doesn't have the same pair of sides being both, we do not have enough information to do this. Not enough info. Again, not enough info is different than saying it's definitely not. Don't make firm statements that you know it's not. Really, it's going on here. You're just not sure that it is. Okay, now, what about this one? Okay, well, we have those two angle pairs congruent, and notice this reflexively shared side allows us to say now we have angle, side, angle congruence between this top triangle and this bottom triangle. Okay, angle, side, angle congruence. Once we know that, we know all corresponding parts are congruent, and we know that this side is congruent to that side, and that side is congruent to that side. That is enough to prove that it's a parallelogram if we have opposite side pairs congruent. So we can say, yes, it is a parallelogram, and that's the symbol for a parallelogram. Okay, this one's pretty basic. A truck sits on a platform of a vehicle lift. The two moving arms, here and here, raise the platform until the mechanic can fit underneath, so it's raising up. Why will the truck always remain parallel to the ground as it is lifted? Because remember, when you have opposite side pairs congruent, then it is a parallelogram, and so opposite side pairs will be parallel. Okay, and since this and this is not changing its length, and from Q to R and P to S is not changing its length, you can see that it maintains lengths of 26 for these two and maintains length of 6 for these two. Then we have Opposite side pair is congruent, so therefore it's a parallelogram. Therefore, QR will always be parallel with the ground. Yep. Okay. Now, the distance from the ground to here is different than what the side length is. The side length doesn't change, but the total height will. Okay. Here, it's just a note that as the arms move, what changes and what stays the same. Again, the lengths stay the same. Okay. Oops. So here is your got it problem. What is the maximum height that a vehicle lift can elevate, that this vehicle lift can elevate the truck? Explain. Try it, come back and restart when you have your answer. Okay, so the idea here is this side has to maintain a length of 6. If you rotate it so that it's, pointing directly up, the highest that it's going to get this truck off the ground is 6 feet off the ground. In order to get any higher off the ground, this length would have to change, and we know it doesn't. So that's why the maximum height can be 6 feet if this is pointing directly up. So again, a quick concept summary is that if you can prove that both pairs of opposite sides are parallel, which is definition of a parallelogram, you know it's a parallelogram. If you can prove that both pairs of opposite sides are congruent, then you've proven that the quadrilateral is a parallelogram. If you can prove that some angle is supplementary to both of its consecutive angles, then we know that it's a parallelogram. If you can prove that both pairs of opposite angles are congruent, we can then state that it's a parallelogram. If you can prove the diagonals bisect each other, then you can state that it's a parallelogram. And finally, if you can prove that one pair of sides is both parallel and congruent, you can state definitely that it's a parallelogram. Okay? And there are some other things like squares and rectangles and rhombuses where the diagonals bisect each other. Why can that be true? Because all of those things are special types of parallelograms. Okay. Okay. Do these lesson check problems and show yourself that you know what's going on with this lesson. And if you do these and you find that you're unsure or you've gotten some answers wrong, good thing to come to office hours or next class to ask about. Anyway, write your lesson check answers down and then restart when you have your answers to check them.